Okay, for example 2, you're going to be given a little bit of information, and you're going to use your sum and identities to kind of navigate through. So it says this angle theta, its tangent ratio is 12/5, and it's located in between 180 and 270 degrees. If you look at my picture, it's the yellow portion. When you have tangent that's opposite over adjacent, so remember theta is kind of sitting here as my reference angle, -12, -5. This was something that was weak when we took our chapter 4 test. With a lot of us forgot to put those negatives in. It kind of messes up on the first couple of questions on our test. So make sure those negatives are in there because we're going to need those negatives from other trig ratios. Cosine is cosine of alpha. This is my alpha picture. Alpha is between 90 and 180, so he's in the blue portion. And you know your ratio is -3/5. For cosine, that's adjacent over hypotenuse. So hypotenuse is your 5, and your adjacent has to be -3. Hopefully you recognize these as Pythagorean triples, so you can put your height in as 4, and the hypotenuse over here should be 13. If not, use the Pythagorean theorem to solve for them. Your job is to find the exact value of this. I don't care what alpha is, I don't care what theta is, I care what the sine ratio is when I add those two angles. So the idea is use your sum and difference identity. So this is going to be sine of theta, cosine of alpha, plus cosine of theta, sine of alpha. You want to put those in and just simplify it. Now on my theta, I'm going to need sine and cosine. So sine of theta, opposite over hypotenuse, -12/13. Cosine of theta, adjacent over hypotenuse, -5/13. Alpha, we'll need cosine and sine. So sine of alpha, 4/5. Cosine of alpha, we already have, it's -3/5. So we're going to put in our values. So 36/65 minus 20/65, 16/65.